I'm going to leave you over to our next speaker. Umo, take it away.
Cool. Thank you, Theo. Good morning, everybody. Hope everybody's doing well. Super pleased to be able to give a talk today on Serverless Puppeteer. Hope you enjoy the talk. Cool, so let's dig in. So cool, bit about me. My name is Amogelang Moloko. You can call me Amo. Currently, I'm an engineering manager at Triplo, but theoretically, I'm also a JavaScript engineer. That's like my primary skill set. So just a bit about Triplo. We are a logistics platform that allow cargo owners and cargo brokers and transporters to automate the entire road freight logistics journey. So we help them save costs and introduce efficiencies into the entire logistics supply chain. So that's a bit about Triplo. If you'd like to reach out, you can reach out to me on Twitter via Prince Ashburton. And then on GitHub, my handle is Amaldinho. And if I'm not doing anything engineering wise, as you can see by the picture, I'm trying to explore the earth as much as possible, as well as just spend a lot of time in nature. Yeah, cool. So that's a bit about me. And then cool, so we can dig straight into it. So I thought, let me just provide some context in like how JavaScript actually helps us at Triplo. So over here, we've got a picture of our product manager, Andre. He's with a logistics controller at Toyota in Durban at their warehouse. So interesting thing in this whole journey, like it's been more about understanding what tools to deliver value for our customers with, but rather understanding like the various problems our customers face. So like in this particular case at this warehouse collects the parts for the different vehicles. So like your Fortuners, your Avanzas, your Hiluxes, etc. So the interesting thing is that here we're dealing with like inbound logistics. And as you can see, Andre is busy sitting with the logistics controller pointing to our web app. So cool. So like I mentioned, we've got a web app and a mobile app. So yeah, our web app is built in React. It's got Redux as a state store. And unfortunately, when the web app was scaffolded, it started using Webpack version 4 rather. So which has actually like resulted in like a bloated bundle size. So at one stage, our bundle size was sitting at about between 40 and 50 megs. We've managed to reduce it to about 30 megs. And that's all due to like doing things like code splitting, splitting out our components into modules with Ant Design into like a separate component library. And all of this has basically helped us reduce our total bundle size for our web app. And then our mobile app, we've used React Native to be able to just write code in JavaScript for both iOS and Android. But what we've adopted with the React Native app is rather partial functionality for a subset of for our customers. And then, quite frankly, my experience with helping the mobile team scaffold the React Native app is that there's been almost next to zero, or like almost zero code sharing between the web app and the mobile app, because I think when React Native first launched, that was pretty much the value proposition, that you'll be able to share like code reuse between the two projects would be high, which was actually not the case with us. And then interestingly enough, with the state management techniques for our mobile app and our web app has been quite different. So obviously I mentioned that for the web app we use Redux, but on our mobile app we use a library called Recoil that was made by Facebook. And as well for our API layer, we've also opted to use React query, whereas with the web app we're using Axios to basically handle all our network requests. So like big variance in difference, and as well as developer experience as well while developing those two particular apps. And then a big part of JavaScript at Triplo is our internal tooling. So when we first started out, we were first writing scripts to basically, seed the database, which we use DynamoDB for, or like remove records, etc., etc. And then at one stage, I actually scaffolded the React app to build specific dashboards till I found this tool called Retool, as you can see from the screenshots. So in this screenshot over here, we've just got like a dashboard that overviews all the loads that are in transit in South Africa at a particular time. So our controllers could actually see what trucks are where and get like a calculation on the distance completed and the progress of the entire journey of any particular trip. So the beautiful thing about Retool is that because all our APIs are like basically SaaS-driven APIs, we can just integrate into Retool and then pull data from our APIs as well as manipulate the data using JavaScript. So that's like been a pretty much it's been sort of a blessing that we've made like heavy investments in JavaScript so that we're able to use it in multiple places. So that's how JavaScript impacts us with our internal tooling. And then so we've got serverless microservices for our backend. So when we first started out, we made the big error of going for a polyglot approach, where each service would have its own repo and it would be isolated from everything, but the services would still obviously talk to each other. But that was because we were using the serverless framework, and this posed like a massive issue with our developer experience, because every time we would onboard a new dev, they would have issues with trying to communicate to other services, or if they were working on a particular feature and that feature required communication from another service, they would have to write mocks to be able to get that data in, and it's kind of unreliable, and it would result in tasks just taking way longer than they needed to. So currently, at the moment, what we've adopted a tool called SST, which basically allows you to create your AWS environment in a sandbox account and basically tear down and bring up infrastructural resources that don't actually affect your dev, staging, and production accounts. And then it also, like I said, so it also clones your infrastructure. So if you've got SQS queues, SNS topics, DynamoDB tables, S3 buckets, Lambda functions, RDS instances, all that kind of jazz, it just takes your AIM credentials and then scaffolds infrastructure for you in a sandbox environment, also allowing you to then deploy to dev and staging. But so the reason why we've moved to this is that we've also moving to a monorepo approach, so that any developer can just pull down our monorepo, run yarn dev, and then basically have the entire Triplo backend infrastructure up and running with queues, topics, event bridge infrastructure, all in one place. So this makes testing and building on this particular base a lot more easier and predictable for our engineers. So what do our workflows look like currently at Triplo? So this is obviously outside of the context of JavaScript itself as our runtime for both our front end and our back ends. So we have a bit of, I would say, e-commerce like activity, because we've got customers like RFG, AB InBev, and Greenrod. So basically, these type of customers, their workloads can run in a cyclical nature. So it's very key that we are not paying for infrastructure we are not using and only paying for what our customers do actually use. So like what we find with Rhodes Food Group is that like during Easter, holiday seasons, like festive seasons and everything, we find a high uptake in activity and traffic on the platform. So that's very key with our serverless infrastructure that helps us to obviously focus on the key problems, on the key business problems for our customers, but then also not worrying about unnecessary DevOps that might result to having capacity that's not on demand. So yeah, that's that. Then we have a pretty much a product focused engineering workflow where we encourage all our developers to actually own a feature across all aspects of the stack. And that's where JavaScript exactly comes in, because someone can pick up a ticket and work on a particular microservice, and then also integrate in the front end without having to worry about handing off to someone else. And that particular engineer will have all the context to write the necessary tests and conduct the necessary functional tests as well to make sure that that particular feature is followed through completely across the stack. And then it also helps our developers develop with a sense of empathy for a particular problem that they're trying to solve. And then lastly, we've got a lot of document generating. So whether that be retrieval, generation, deleting them, surfacing, or whatever aspect of documents, that's what a lot of our workflows relate to. Because not only do we have documents for our the loads on the platform, we have documents for the companies on the platform, for our drivers, for our trucks, and our trailers. So document generating is like a key part of our workflow for almost any service that we maintain at Triplo. Cool. So I just want to go over like what are my opinions on JavaScript like as of 2023. So like a key thing is that like typing is absolutely essential for any JavaScript project, especially one that you're going to send out into production and have the goal of maintaining and have customers use. This is purely because I've burnt my hands a couple of times by not using TypeScript and typing everything. So to give you an example, we needed to implement a search feature, so we opted to use OpenSearch. And because we had not been using typing for our backend infrastructure, especially for our DynamoDB table, what had happened is over time the format of dates had started to change. Properties and objects had the structure of those had to change because of business requirements. And so by the time we had started syncing this data from DynamoDB into our OpenSearch clusters, many of the times we would get failures in our OpenSearch clusters, and our customers could not search or the data we tried to index, purely because OpenSearch is saying, look, you've already given me this particular property, but now it's changed like 500 times or whatever. So like you can really burn yourself if you're running a JavaScript project and it's not typed. And then I feel like now is like the perfect time to embrace JavaScript's ability to prototype rapidly, as well as collaborate with your teammates. So by that I mean having feature deploys where if you're working on a particular pull request, you can then deploy that particular pull request via your branch name. That allows you to prototype particular ideas and services and features like in the blink of an eye, as well as getting these features out to either your customers, but most importantly, rather your internal team members, so they're able to give you feedback on whatever you're making in an iterative nature. And I think that's the benefit of JavaScript. But also more importantly, in terms of the access to the libraries you have and the community around it, because like basically for everything and anything, language is alive, and there are people behind it that are actively working to make things better and also assist you in the event that you have issues. So yeah, that's that. And then also a key thing when it comes to JavaScript, I think even more so with the collaborative nature, is that there's obviously a package that's being released almost monthly, weekly, daily. So it's like it's very important that you choose your adventure wisely for your entire stack. So what do I mean by that? I mean, if you're starting a new project, like we can take, for instance, state management. There must be like over 10 production-ready state management libraries that have close to over 2,000 stars. So obviously you'll sit there with decision fatigue, but it's very important to make a decision as to what type of roadmap you're gonna choose for particular libraries, because everything is about trade-offs at the end of the day, and we obviously live in a world to make things to solve people's problems, our customers' problems. So like particular choices in in your particular stack, especially when it comes to JavaScript down the line, it can impact you. So I read an article the other day about Sentry. I'm not sure if anybody knows Sentry, but they are an error monitoring tool. So for their unit tests, they were using Enzyme, and they could not continue writing their tests or testing their code on new React features like hooks and everything, because Enzyme was using React's internals to actually run the test. So in the end, they had to spend about a year migrating to a React testing library to be able to support the new features that React has, like hooks, etc., just to be able to test their code. So in the end, obviously, we don't live in an ideal world, but there are certain things that you can optimize for from the beginning or midway through a project to save yourself some future pain. All right. So what is serverless? Just a small recap. So serverless, I've used serverless more as a computing methodology where your infrastructure is provisioned for you and it's on demand, where basically you just send up your code to a particular service provider and they take care of the rest when it needs to be invoked, when it needs to be started, and all that kind of jazz. So you're not necessarily worrying about the compute power that your infrastructure needs to handle, and it will just scale with whatever traffic it's given. All right, so the key players, the primary players are Amazon's AWS Lambda, Google Cloud's Cloud Functions, and Microsoft Azure's Functions. So those are like your three go-to players in the serverless market. But obviously now Netlify and Vercel are obviously coming in with some fantastic offerings with their serverless functions that just seamlessly integrate into their hosting infrastructure. So key things to obviously note about serverless, or from my experience, is that it requires different mental models for certain things. So the two examples I will be alluding to are more around handling of media and auth. So by media, I mean audio, images, and video. So obviously, like for instance, if you're trying to upload something into an S3 bucket that's over a particular size, you then have to use assigned URL to be able to upload a particular item into a bucket, and then also in addition make a reference of the key from that bucket into whatever database you're using, because you obviously can't just send binaries over the wire over your API, because I'm not sure about GCP and Azure, but I know in the AWS Lambda world, it does have a payload limit, which I think is about 6 megabytes. So like those type of limitations obviously bring about different mental models and require you to architect your infrastructure a lot differently than you would before, when we had like the likes of when everybody was using Express and all those kind of tools. So in addition to that, we've got authentication and authorization that needs to be handled differently and thought about differently. So in our case at Triplo, we are fully invested in the AWS platform, and we're using Amazon's Cognito. So the benefit in this case is that because we're using Amazon's Cognito, which is an identity provider platform that basically manages all your login and sign up and forgot password information for you, is that using that particular user pool, we can then authorize the use of different services by the user pool, whether it be an S3 bucket, using EventBridge, or getting access to a particular row in a DynamoDB table. That particular model of architecting our architecture has its benefits and its disadvantages as well. So those are just some of the kind of things that we've had to be aware of over the years while adopting serverless at scale. And then lastly, the cool thing about serverless is that then it requires your architecture for your platform to actually be more event-driven. So going back to the example of the S3 buckets with the use of media, once an object is inserted into a particular bucket, we can obviously then listen to events from that bucket, and then use AWS Lambda to either update a record in the table, fan out an email, or run another event that starts a batch process job, or run particular cron jobs on those type of things. So the upside to using serverless is that it really encourages you to have more of an event-driven system that have listeners and jobs that expect a particular event in a particular format, and then it just takes care of the rest to either send out emails or fan out different requests to either your database and all those kind of things. Cool. So now we're getting into the crux of the talk. Okay, so we've covered serverless, and now let's just briefly whiz over Puppeteer. So Puppeteer was made by the Chrome dev team at Google. So basically, it's an API for Chrome and Chromium. So majority of the things you can do with your eyes and your hands while using the browser, you can basically do via an API in Puppeteer, and the possibilities are endless. And I'm still trying to wrap my head around what else is still possible to do besides the obvious. And then the alternatives to Puppeteer are Selenium and Playwright. And Playwright, for anybody's knowledge, is made by the team over at Microsoft that runs the Edge browser. Cool. So its core use cases. Its core use cases are for automated browser testing and end-to-end testing. So that's like its core use cases. But funny enough, I think Lunga gave a talk yesterday on AWS's device farm, which has an option to allow you to also test your apps in the browser. However, like, I'm just trying to think, like, I mean, if I'm an engineer at Figma or Miro or whatever, I would still opt to use Puppeteer, just because of the complexity and that you can actually get from Puppeteer's API in order to automate your entire browser, to automate your applications feature testing for your application rather. And then another core use case is dynamic document generating. So it gives you the ability to take screenshots of a particular application, or even take a screenshot and then convert it into a PDF, and then you basically have a binary file of your particular application. And then it's got cool APIs like being allowed, basically, I'll show you after we're done with the demo, that you can basically send through HTML, tell it to click on particular buttons. And so if anybody's written unit tests before for React or Vue with the React testing library, it's got a similar API where you can basically crawl the page for your ARIA labels or your class names, and then programmatically give it instructions to go to the next page or insert data into a form and what have you. Oh yeah, another use case I forgot to add here is actually for web crawling. So I think I'm pretty sure the folks at OpenAI or anybody that's running a GPT-3 model must be using some form of a headless browser to be able to automate the scrolling or the scrapping of all those pages to present those results for their models. Cool. So let's dig into some examples in the wild. So over here, I've got a receipt from Uber Eats. So basically, the driver had delivered the food to my house, and then immediately afterwards, I get this email with this receipt. And obviously, Uber can't be hiring people to take every order and then manually make an invoice for everybody. So they are definitely using some form of either a Puppeteer or whatever it might be, or a headless browser under the hood to generate all this information. So as you can see, it's a total of my meal, and then a line item of everything in the beef share bag, as well as my credit card information and my address. And yeah, so that's basically an example of Uber using this in the wild, and I'll show you later once I go through the code that basically all this is easily generatable by using HTML and CSS, and all this data is just basically you can ingest it via an event or mutation or a post request to basically put the user's information inside this document. Another example we have here is from Westbank. So this is a monthly statement for my car. So I've obviously had to blur out some sensitive information here. But I mean, as you can see over here, you can see that every time the interest rate has increased by about 25 basis points, it then will put that in this particular statement, and then it will also tell me will also be calculating how much I have left of the term of this particular agreement, and like the sum. And below there's another screen part of the PDF that I couldn't share, but it was just basically showing like my balance on my statement and the previous month's payments as well. And then, so basically all this information is definitely taken from a database, and Westbank must be close to 1 million, well over in the millions of credit agreements for vehicles. So if I was an engineer at Westbank, this would be to generate this agreement using Puppeteer or any headless browser would be another, if I was an engineer at Westbank using Puppeteer, or any headless browser would be an obvious choice to fulfill this business requirement that we have over here. Cool. Last example. So at Triplo, where I work again, this is how we use Puppeteer in the wild. So basically, whenever a customer creates a load and the transporter says, yes, I can move the load from Germiston to Botswana, what then happens in the background is we send out an event to one of our services to say, hey, we have a customer here and they want to make a load confirmation, and then here's the detail of the load. So basically all the majority of the data on here is taken from a record in DynamoDB that has information about a particular load. So you can see the transporter's name, their ID, the ID of the particular load, as well, the rate, the driver name, truck registration, the front and the rear trailer, the weight of the load, and the GIT required. So GIT is basically the amount that the load is actually insured for. And then in addition to that, we've got loading information on the loading and the offloading dates, as well as the address. So then, in addition to that, under the section where it says payment and capital, this is basically none. But what we have is we have a service which we call admin settings. Basically, for each particular customer, they have different payment terms. So the payment terms is basically your agreement to the transporter for how much, when you're going to pay a particular transporter. So in this case, this transporter isn't using our chip fulfillment services or early settlement services. So if they are, then this particular Lambda listener would then go and see, if they are, do they require fuel for this particular load? And then it would make the relevant calculation and then populate it into this load confirmation PDF. And then in addition, this load confirmation. So first, to trigger the load confirmation, we bring up this whole entire form in a digital format, and then click accept. Once it's accepted, the load confirmation event then fans out to the relevant services to generate this particular PDF, and then it's inserted into an S3 bucket at any time for both the cargo owner and the transporter to be able to access this particular document, because this is like a binding agreement between the cargo owner and the transporter now that this is exactly what they've been tasked to move, and they would also send this load confirmation out to the border as well. Cool. So I think it is demo time. So I'm just going to exit this, and then show you the demo. Cool. So okay, cool. So for this demo, a while back, I created a course where I created basically I showed people how to make a full stack serverless app in React and Vue that basically allowed you to book fictional vacations to the moon. So we've got a whole bunch of listings over here, and then when you go to each listing, it allows you to book the particular fictitious activity on the moon. So what I've done is I've scaffolded a Next.js app over here with all these listings that I've just shown you. And then so basically, once you click on either one of them, you'll be able to generate an invoice. So I've just clicked OK. It's busy generating the invoice. So we're just giving it a moment. Cool. So that's done. I can click over there and boom, I've got the invoice for the particular for this particular trip that I have that I've partaken in. So this particular invoice. So in this case, I've just took a screenshot. So it's a PNG image that I've dumped into an S3 bucket that you can see over here. But like I said, you can also instruct Puppeteer to turn it into a PDF and what have you. So all this information over here is all dynamically generated from the web app. So let's take a look at how I went about doing that code-wise. Cool. So I'll start with the backend. I hope this is big enough for everybody to see. Okay, cool. So let's just go over the backend. So with the backend, I used a tool called SST. So basically, what I forgot to mention about SST is that it allows you to create your infrastructure with Amazon's CDK. So you're like truly creating infrastructure as code. So as you can see, I just have to import like the GraphQL API and the S3 bucket methods, and then basically all I'm doing is just basically instantating infrastructure via functions. Versus before with the serverless framework, you'd have to do all of this stuff in YAML, which is an absolute nightmare. Then likewise here for my GraphQL API. A simple function where I'm just basically giving it its environment variables as well as its external modules. So interestingly enough, to get Puppeteer working on in a serverless environment, you need to use a Lambda layer. So a Lambda layer is basically, in short, is another way for your Lambda to access like a particular package or a subset of code to be able to run at runtime for your particular function. And that's another issue with serverless, is that majority of like traditional tools like Puppeteer, or say for instance you want to have subscriptions on your like WebSockets, you're going to have to find a different avenue or do some more research into how to make it compatible in a serverless environment. So obviously, so for this one, you can't just npm install Puppeteer. You've got to add this Lambda layer over here, and then in this index file, you can simply just instantate the stack that I've just made, and then this will then create a CloudFormation stack in your AWS account. Cool. So that's the stack, and then basically in this packages directory is where you will have all your code that talks to your functions, your your DynamoDB tables, and your S3 buckets. So I'll go over here. So cool. So basically, I used GraphQL. So I just had one mutation that allows you to generate the invoice. And it accepts an input for the name of the trip, the guide, the price, and the trip name. Sorry, the name of the customer rather, and then the trip name. So if I go over to our mutation, so what I have here simply is I have a function that's called generate buffer. and then I have a function called invoice data template. So I'll go to the generate buffer function. So this generate buffer function is the core integration into Puppeteer. So I'm basically just pulling in the Puppeteer library, launching the browser, creating a new page, and then setting the content. So the content is the HTML that I've sent through, which is basically the background of this invoice and these lines, and the dynamic data from the web app. Cool. So once I've set the content, you now basically have your browser is now like alive, or should I say, is up, and it's got content into it. So then you can either from here you can either go .pdf to create a PDF, or go .screenshot to take a screenshot of whatever you've put into your browser. And then once you're done, you have to close that session. And over here, all I'm doing is returning a base 64 object. Okay, so I've got that, and then now I just want to show you how I went about generating the template. Cool. So with the template, it's just basic HTML, and then I've managed to install Tailwind via CDN. Cool. So that's all the head and the scripting part. And then basically I've got a function that returns back the HTML, and then basically has the customer info, which is the dynamic information that you're able to then put in whatever part of the HTML that you want to create. So obviously my invoice doesn't look so pretty, but I mean, you can get a designer or whatever, or spend some more time into basically making whatever you can imagine, and then putting all the dynamic information inside of the template, because basically all you're using is HTML and CSS. And obviously for whatever library you use, I don't think you're limited, because majority of modern libraries have their packages available via CDN. So that's how I generated that particular template. And then if I go back to the mutation, and then all I'm doing is just basically turning the buffer, taking the buffer putting it into an S3 bucket over here. And then all I'm doing is just basically inserting the data into an S3 bucket, and then returning the string for where the S3, where the newly created PDF is actually located. So I mean, like nothing fancy. So this is obviously the document generating aspect of everything. However, like I said, you can use it to automate your. Oh, sorry, I just need to charge my laptop. Cool. Sorry about that. All right. So as I was saying, yeah. So basically, obviously, in this particular use case, I'm just creating a screenshot, but like I said, you can use it more aggressively to write your end-to-end tests and all that kind of jazz. So that is the back end, and then I'll briefly whiz over the front end. So the front end is a simple Next.js app that then let me go to components, basically, that has a trip list inside that basically takes a payload of all the trips, and then I basically just loop over them, and I'm using Apollo client to invoke the mutation in order to start the whole process of generating invoice. So that's pretty much the demo. I can open it up if there are any questions. I've also got a link to the slides, and I'm going to post a link to the slides and the entire backend and front end, which is available on GitHub in the chat if anybody's interested and wants to take a look. Cool. That's all, folks.
Thank you, Amo. I am going to open the floor up. So if anybody has any questions, please pop them in. We have a few minutes to spare.
Cool. I'm just going to post a link to the slides and the GitHub repo.
Sure. Perfect. Alrighty. Thank you so much.
Okay, cool.